change the game on you guys and change the location. You guys found this right away, so you passed the first test. Okay, so good. All right, so looks like people are mostly settled. Welcome. This is the 43rd monthly meetup with the HPC and GPU Supercomputing group of Silicon Valley. And we're very fortunate to have Baidu hosting us today. And Baidu Research has been here in Silicon Valley in the past year or so. And it's great to be able to have their support in our meetup. And in terms of today, just in case you guys need the Wi-Fi login, there it is. But I'm going to give, there's actually quite a lot of new faces today. Well, let me introduce a little bit about our meetup. Our meetup group has a mission as a group for the application of cutting-edge HPC technology to the cutting edge, to applying those to business problems. And our emphasis is on the useful application of supercomputing by practitioners for practitioners. In every meetup, we invite some practitioners in the field to come and share their experience with us. And oftentimes, and actually as I look around, there are many powerful practitioners in the field joining us. And you actually hear from some of them as we open the floor for them to share some of the news about the field in the past year or so. We have many sister groups around the United States. Some of the biggest ones are in Boston, Austin, and Florida, and Chicago, and all those places. And right now, the Silicon Valley one is the biggest, and we're almost reaching 1,000 members. And thank you for joining us today, but there is actually a lot more who wasn't able to come.
You say we're the biggest, but you kind of forgot New York.
New York is not there anymore.
What?
Yeah. So now we're the biggest. And today, we're very fortunate to have support of Baidu, and I'd like to invite Brian Catanzaro to give us a quick introduction.
Hi, everybody. So I'm Brian Catanzaro, and I'm part of the Silicon Valley AI Lab here at Baidu Research. I wanted to welcome you all out here today. I'm really excited about the talk that we're going to have today. I think there's some interesting things that I'm looking forward to learning. I just wanted to sort of introduce Baidu a little bit to you. So Baidu is the largest search engine in China. Baidu serves hundreds of millions of users every day. Because of that, Baidu cares a lot about AI and AI research. Recently, Baidu has several research arms. One of them is the Institute for Deep Learning. There's a bunch of researchers from that group here. There's also a new Silicon Valley AI lab that I'm a part of that's led by Adam Coates, and our chief scientist is Andrew Ng, who's over there in the corner. Baidu's investing a lot in AI because AI technologies are core to a lot of internet businesses these days. Asking questions about search relevance, or ad placement, or image search, or any number of products that a company like Baidu needs to provide, they need to be powered by AI algorithms. And so that's the job of the Silicon Valley AI Lab, is to sort of innovate on those algorithms and provide new solutions to these interesting problems. So we have a really strong systems focus in the Silicon Valley AI Lab. So we have a lot of AI researchers that are doing great work on algorithms, and then we have a great team of systems people that know about HPC and GPUs, things like MPI and CUDA and OpenCL. And we are looking to hire more people. So if you are a strong systems programmer and you want to apply all the knowledge that you've earned over the years about HPC and GPU, please send us your resume. You can either talk to me after this, or you can send your resume to Celine and Eloise. Celine and Eloise? Celine?
I'm Celine.
So that's Celine. Yeah, so she would love to talk to you as well. So with that, thanks for coming, everybody, and we're really happy to host you here today.
All right, thank you. Great. So for those of you who wasn't able to join us in August, this was what you missed. Last time we talked about M-Logic, all-spin devices and circuits for future HPC. And we had Professor Jimmy Zhu from Carnegie Mellon joining us, sharing some of his vision about what is the next step after the traditional silicon devices. And today we're very fortunate to have Felipe and Sharon here. Where are they? Ah, there. And they are going to be sharing with us a new library from NVIDIA, cuDNN, Deep Neural Network. And they're going to be sharing a bit about that just in a little bit. But before that, usually what we do, for those of you who are joining us for the first time, we do a quick rehash of what happened in the past month. What are some of the news in HPC and GPU supercomputing that people may want to learn more about? Well, for this one, it's definitely one piece of news that's pretty prominent, and you're going to hear a bit more about it in a little bit. But it's a GPU accelerated library of primitives for deep neural network. And it emphasizes performance and ease of use and low memory overhead. Well, I'm going to leave them to talk about all the different benefits and how to use it. But in short, this has been demonstrated in some of the infrastructures in the Berkeley, from Berkeley, the cafe infrastructure for image, deep learning in images, that it has been demonstrated to be quite a bit faster than just a typical GPU implementation. Actually, there's also quite a few pieces of news from NVIDIA. Anybody would like to share a bit more about other news coming out of NVIDIA this month?
Jike is looking at me. It's funny how that all works. Sure, I have a little bit of information.
You want to introduce yourself?
Oh, sure. My name is Steve Worley, and I'm a GPU geek like all of you guys, you know, and girls too. NVIDIA, of course, released their latest GPU, which probably many of you have read the specs and so on. But everything online, of course, is always talking about its graphics performance because what they released was the GTX 980, which is a consumer GPU. It's not for HPC. It's on the Maxwell architecture, but it still is important to us because we're very interested, of course, in any new GPU that we could use and abuse. So the GTX 980 is using the Maxwell architecture. It's the second generation Maxwell, of which there's probably going to be a third one as well. It's the GM104 if you're keeping up. So this card is not the full power HPC card that we'd be expecting. It's not the same as a Titan or a Titan Black level or a Tesla level, for example. So it's really a consumer card, but it has performed performed extremely well. In particular, its single precision throughput is really fabulous. And this shows a lot in the video games that everyone tests about. But even for CUDA programmers, it's actually pretty excellent. Already people have taken and, like the previous release of Maxwell, which was the GM107 back in February, the GM104 has kept the efficiency and throughput of that and scaled it up even further. In particular, it's hitting enormous throughput. NVIDIA itself, during the keynotes at GTC, was talking about how the performance per watt of Maxwell for single precision would be about double that of Kepler. But this card, which is already not the flagship yet, but the consumer one, is actually at about 2.5 times the performance per watt of the old Kepler generation. This is using actual SGEM measurements where Maxwell is able to get the full throughput of all the FMA units on it, which of course applies to us a lot because every time you're doing matrix multiplies, that's our limit. So it also shipped a new 6.5 toolkit, which includes support for the new Maxwell. There is a new update to the programming model, very minor, but the shared memory per SM is basically boosted up, so now there's actually 96K instead of 64 or 48. So very minor programming changes, no big deal. This is still not the double precision engine we're looking for. The double precision on the GM104 is only 1/32, which is nothing. When the big Maxwell will come, everyone's speculating, perhaps it'll come in November when supercomputing happens, or maybe it'll be next year. Nobody quite knows. but the performance of this one has really held up to NVIDIA's promises, and everyone's pretty happy about it. There is some other rumors too. There's rumors that the mobile core from NVIDIA, the Denver core with the K1 Kepler-based GPU attached to it in the SoC, will be coming out soon, probably with the Google Nexus 9 tablet. That's rumors, but there's been so many leaks about it, it's probably going to happen soon. And the last thing, which is also important, a little change topic, is GTC. That's the GPU Technology Conference. That has, you can give talks there, and there's a time limit to signing up for giving talks, and that's October 6th, so don't forget about that. So that's my NVIDIA news that I happen to write down. So.
Thank you. Thank you. And also, actually, how many people are following the Oracle Open World this week? Good. Because people who care about performance usually don't use Java. But for people who are using Java, they might care about performance. And some of the new features in the new OpenJDK project are now supporting some of the capabilities that allows you to better integrate GPU type of functions into Java. So before this, there are actually ways where we can integrate GPU-related functionalities into a Java program through the Java native interface, through offload solutions like Prod Pi or JOCL and a variety of other solutions. But for those, you actually have to programming another programming model in order to integrate GPU-related code into a Java program. But now with Java 8, there is and this open source OpenJDK project, Sumatra, you can actually do that native. And if you want to find out more about that, you can go to that website and find out a bit more. But if you have any friends who are diehard Java fans, now you can get them to use GPUs without actually getting them to learn another programming model. Also, this is a little bit old, but I'm not sure if people have noticed this. It's a commentary actually that came out this month about whether the FPGA whether 2015 will be the year for FPGA. Some pundits speculating about how the FPGAs could potentially change the world in terms of doing search and deep neural network training. But I just had a chance to talk to Andrew earlier today, and he has shared that his perspective is that's not going to be the case. Well, what happened there that was announced was Microsoft Bing was using some FPGA board for search. And they actually tried out, well, the article says that they tried out some Xilinx-based solution, but it was a little too power hungry. So they tried out an alternative solution that happens to be based on the Altera chips, and it worked out pretty well. And in fact, when they were measuring the performance for latency versus throughput for the query handling capabilities, they were getting 2x increase in throughput at the same amount of power, I believe, or the same. What's the x-axis there? Well, yeah, at the same latency. Sorry, 2x the throughput at the same latency. And also, there was some research that's done by some researchers at Baidu that used FPGA to accelerate DNN, but that's relatively more limited research, and a lot more is on how to use GPUs to accelerate DNN frameworks. Anybody working in those domains about using FPGAs for supercomputing, and any other applications that you see that people are using? All right, go ahead.
So FPGAs have been used for lookup tables for years, and they're being used that way in data centers today. On hot chips, a graduate student from university in Italy introduced C++ to write to FPGAs as another option in the development kit tool chest. The word on the floor, and concurring with people from Nalitech, use FPGAs for various forms of acceleration, is when Intel bet Broadwell attached to an FPGA, that set a milestone or a benchmark in the industry. So whether or not the FPGA phenomena is to be believed, it has this weight of Intel positioning themselves and their processors around one. So you have that provided some weight for the FPGA argument, but I wouldn't say that it's actually decided that. But the fact that there was C++ now addressing FPGA development was thought to be particularly attractive by some people there. And it probably was the astonishing highlight of hot chips.
Interesting. Thank you for sharing that.
So what is the C++ programming model compared to the C offered? I mean, those efforts in 10 years ago, music programming.
What I would do
is one of the major progress over there.
That's a good question, and I'm a business development person, so what I would do is I go to the Hot Chips website and look up the student project posts and find that one, but it will be there.
Okay, because I'm interested to see if there is intermediate language being used. In other words, C++ being compiled to, for example, OpenCL, and OpenCL can compile it down to other intermediate languages, then go to the FPGAs. I'm not sure if they have the direct approach or they just go to
The students' poster board there had benchmarks of various languages that could be used to program them, so I'm sure you'll find that when you look for it. I'll look through my notes, and Jika knows you. Does Jika know you?
Yep.
I'll look through my notes and find the person.
Great, thank you. Anybody, so we had some speakers here at the meetup talking about OpenCL on FPGAs. Anybody is following that area about how Altera is working with OpenCL on FPGAs?
I don't know anything to add, but yeah, it's a very interesting story. Had some interesting
Did you
conversations.
speak up?
I've had some interesting conversations with people that know FPGAs, especially in this room, and their take on it was that even though it's an OpenCL, the best results will be programming it in OpenCL as if you're programming an FPGA rather than programming it like a GPU.
Huh.
And the person who said that can speak up or not.
I see.
I mean, the thing is that you cannot really do floating point, right, on FPGA. I mean, you can, but it's a waste, right?
Huh.
Right?
No, that's not
Oh,
true.
the new ones are different.
Yeah.
Really? Can you?
Yeah,
Altera
that-
have hardly floating unit.
Yes.
Yeah.
But gates by gates, like
Yes,
you
they
really
have
think
a
you can compete with
hot
GPU?
wire floating point circuits.
Yeah, so
Somebody could
Altera
go hog
introduced,
wild
that's
and
what
make a precision
Altera
model.
introduced a floating point unit recently, so it wasn't there in the last 5 years, but now it is available and it's very, very low power. But I think if you think about FPGAs, one of the biggest challenges we saw was that the algorithms like adaptive algorithms are pretty good, which will run really fast, but the routing overhead is extremely high, so you may actually lose a lot of power when you do that. So that's the kind of the trade-off you have to do.
Thank you for sharing that. Great. All right. And there is a IEEE Big Data conference coming up, I think in late September or late October. I'm sorry, I didn't place a date on there. I think it's something like 24th to 25th of October. And there was a few FPGA, GPU related paper there. And one of the things that we've been always tracking in this meetup is how is big data and HPC converging. And one of those convergence point is GPUs. Since GPU has a lot of throughput and is working, it's got a lot of processing power. And what has been interesting to note is that for big data analytics, there hasn't been as much work, other than a small piece of work that was done by, I would say Mark. Anyway, so one particular company that was doing text processing and entity extraction using GPUs for big data analytics. But just now, this year, we're beginning to see a lot more interest from the big data space in using GPUs. But if you look at the titles, the way that they're using the GPUs is still quite elementary compared to the real deep learning type of usage of GPU usage. anybody's familiar with the use of GPUs for big data solutions here? Yeah. Usually when I take that poll, that is a good indication of where the field is, because we have a lot of experts around here already. So any other thing to add about the state of the industry? Do you have something?
Jike looks at me again. So, yes, there is one other interesting thing that's happened in the industry, especially for on the GPU side, and that, of course, is the state of OpenCL. At SIGGRAPH this year, the Kronos Group, which administers OpenCL, announced a new 2.0 revision of OpenCL, which is very interesting, but of course pointless until there's actual drivers to actually run it on real hardware. Well, both AMD and Intel, in the past week and a half, I believe, have released drivers and compilers, the entire developer toolchain, to support OpenGL. For AMD, this means you can run OpenCL on both their GPUs as well, of course, their CPUs. And on Intel, they did the triple threat of having their IGP integrated processor doing OpenCL, as well as CPU, as well as Xeon Phi as well. And OpenCL 2.0 brings a whole set of changes to OpenCL, which is getting a little bit stale. As a quick summary, you can imagine it bringing OpenCL's API up to a level comparable to NVIDIA's. Still a little bit below, this is an arguable point, but it adds things, for example, such as being able to share memory between the CPU and GPU using the same memory. It's basically a virtual memory management, much like CUDA has. There's dynamic parallelism, again, just like CUDA as well. There's a generic address space, which will help, especially in the future, for more heterogeneous compute. Atomics have been added using a C++11 style access method, which is fine. There is one new feature which is not in CUDA, which is kind of interesting, and that is a way of processing data via pipes. So it's basically handling a FIFO task list or data list for you. And that's something that's not in CUDA, although I guess could be emulated. So again, so OpenCL is not quite the same level as CUDA, but now the interesting part is that because both AMD and Intel are now supporting it on CPU and GPU, there's suddenly a whole bunch new hardware which can be accessed using this OpenGL 2.0. So it's certainly becoming a lot more interesting to try and program for.
Thank you.
Yeah, to add on that, I think Intel's release was very interesting in the sense actually cross operating system support committed. So in other words, the Windows, Linux, as well as the Android are supported by Intel devices. So that's an important point to take.
I have a comment on your question on the GPUs and data centers. I've been looking for that on my hunt for how hardware is productizing. And the answer is, I can't find it yet. And they say they do. The public cloud providers say, yes, it's here. They're still trying to figure out how to implement it. And there's competition for processor arrays and flash arrays. We actually have multi-core processing arrays in flash. And so I think they're trying to figure out where in the system architecture to put it.
Sorry, can you clarify what it is? GPUs or FPGA?
GPU acceleration. Generally acceleration. Where do you accelerate specific types of algorithms to do specific types of near real-time search in 256 terabyte flash arrays in the nearest real time you can get. That'll have a high level of service. SLAs will be very high, as well as the cost to maintain that type of environment, all the way down to the client and the applications developed. But they're working on that. The off-the-wall application that you asked for GPUs, in addition to other accelerators, x86 RISC decode, ROPS, RISC ops. What RISC ops, what x86 instructions will be the most likely utilized most of the time in data center applications, and is that subset of instructions worth not translating from an emulation standpoint, but actually programming a GPU or an FPGA or a DSP to do the RISC translation. So that's a far out wild one, but there are people thinking about that who want to strip massive tons of cash off of Meetup.
Thank you.
That's a crazy great idea.
It's a crazy great idea.
Who's doing that?
That's how the ARM community is going to have to do it. They're going to do it with accelerators on the data plane side, on accelerators, not on the ARM side.
Pretty cool, thank you.
Sure.
Great, thank you. So in the interest of time, let's go forward, concluding this portion of the meetup. So for those of you who are new to OpenCL or to GPU programming or HPC programming, OpenCL, there are some pretty good reference books for you to be introduced to the field, as well as a whole bunch of pretty good books for GPU development, as well as for parallel programming patterns. And now it's a time where I see many new faces. It's great to have you do a quick introduction of yourself. We'd love to hear from you about a few things, who you are. For example, I'll do a quick introduction myself. I'm the organizer for the meetup over the past 3.5 years. And I've been working in the area of multi-core, many-core, and parallel computing technologies, and most recently for machine learning purposes. And I'm a national professor at Carnegie Mellon Silicon Valley campus, where I helped them start a CUDA Research Center and CUDA Teaching Center. And I'm also a director of data science at Simply Hired, a job search engine, where we're using machine learning to help job seekers find the jobs they like and help employers find the human capital they need. And previously, I've worked in many areas in HPC and GPU supercomputing. But my personal goal for the meetup is to meet great people like you and to stay up to date. So shall we start from this side?